Hello everybody and welcome to the next round of videos for the ITV program at Los Angeles Community College District. I'm going to start with section 3.3, and this will essentially serve as the homework assistance for both sections 3.3 and 3.4, as the techniques we're going to learn in this section are going to be applicable to that section as well. So anything involving fractions, I'm certainly I'll be happy to show the answers, but I'm not going to show all the fractional work, as the scientific calculators that you should be having in hand should go ahead and already do that work for you. So my expectation is that you're not going to show the work by hand for doing fractions or decimals. That work should be done in a calculator. So we're going to go ahead and take a look at question 1. And in this case, we are multiplying a monomial times a monomial. And if we take negative 1/5 y squared times 1/4 y to the 9th, we just multiply the numbers, and a negative 1/5 times positive 1/4 will give me negative 1/20. And then y to the 2nd times y to the 9th will give me y to the 11th, as we add the exponents for that particular question. Okay, that's simple 1. Number 2, these are 3 monomials being multiplied, so I'm just going to go ahead and multiply all the numbers together. 2 times negative 4 is negative 8. Negative 8 times negative 4 is negative 32. And because I have x to the 8th times x to the 7th times x to the 4th, just to kind of show this out. Oops. The rule is I add these exponents together, so that's going to give me a total of negative 32 x to the 19th. And that's going to be the answer for question 2. In questions 3 and 4, we are looking at distribution now. So let's go ahead and take a look. I'll rewrite this problem here. Negative 2a times a plus 5. So what might help is actually they have something a different color to write this with, perhaps. I'm not sure if I have anything that's going to, I do have red. So maybe that'll stand out a little nicer. So what I'm going to do is I'm going to write this on the outside as in red, and then I'm going to write this here in purple. Now, I won't do this for all the work I'm going to do, but just for these couple examples we've got coming up. So when I distribute negative 2a times a plus 5, it means when I distribute this, I'm going to write negative 2a times the a on the inside, and then this is going to be plus, and then this will be negative 2a times 5. I want to make sure that everyone can see that okay. So if I multiply all this together, negative 2 times this 1 is going to be negative 2. A times a is a squared, so that's negative 2a squared. Plus and minus will just make a minus. 2 times 5 will give me 10, and that'll be 10a for my final answer to that question. I'm going to move this up a little bit here. If you want to get that, make sure to copy that before I move on. And I'm going to show the next set of work here. So in question 4, it's asking me to multiply a negative y times 7x to the 3rd minus 2x squared plus xy squared. Make sure everyone can see this. Plus 3y to the 3rd. Now, the expectation is you should kind of be able to see this mentally, but in case you still struggle with this idea, I'm going to go ahead and write it out using the 2 different colors. So I'm going to have just kind of write this out with a space to write that negative y. And make sure again that everyone can see that. So in each space here, I'm putting negative y, negative y, negative y, negative y. And that's what it is to distribute. So what we're going to do now is we're going to look at each part of this separated by like the minus and plus sign and do the multiplication. So we have a negative y times 7. So that's going to be negative 7. That's because that's a 1 understood to be there. X to the 3rd times y. Well, there's no y to combine this with, so we're just going to write this as x to the 3rd times y. Minus a negative. That's going to give me a plus. So that's going to be 2x squared times y, 2x squared y. plus or minus, so that's going to be negative. We have y times, I feel like I didn't write something in this question. Yeah, I'm missing something here, guys. So in case you might have noted that, there's supposed to be a y here, and I failed to write that. So because I didn't have the y here, this squared is on the x, not the y. So y times y will give me y squared in this particular question. So just something I overlooked. I want to make sure I caught that and try to make fewer errors in this video here. So I have negative y times xy squared. That'll give me negative x and then y to the third. And then the last part here is going to be plus or minus, which would be minus y times 3y to the third, or just 3y, 1 plus 3y to the fourth. And that gives me the final answer for question 4. So fairly complicated question, but hopefully as you get comfortable with the rules, you'll be able to do that visually without too much hassle or headache. Let's go ahead and take a look now at question 5. And on the next page, you're going to learn how to do, or next section, you're going to learn how to do questions like number 5 with a process called foiling. I'm not going to teach foiling because they do an adequate job of that in the videos you have for the class, but I am going to show you a different technique, what's called a multiplication box. So in x plus 3 times x plus 7, you have a binomial times a binomial. And because you have two terms in the first polynomial and then two terms in the second polynomial, there's going to be a total of 4 different multiplications that need to take place. Now, presuming you were in class, you would have seen this technique, but again, I'm going through it again in case you need that additional reinforcement. I'm also going to be doing this with multiple examples. So here, we're going to have x plus 3. Here we'll have x plus 7. So what I'm going to do is I'm going to multiply everything through, like x times x will be x squared, x times 3 will be 3x, 7 times x will be 7x, and then 7 times 3 is 21. As I mentioned in class, you can combine on the diagonal about 90% of the time. That's going to be referred to as the peanut. And when I do so, they'll give me x squared, 3x plus 7x, 10x plus 21. Now what I'm going to do is not do the questions I did in all the classes, but I'm going to do some questions that I didn't cover in class. The first one among them being question 6, which when students may first see, feel like they may get a headache from it. So we have x plus 2 over 5 times x minus 1 over 5. So again, when you're doing a question like this, we're going to go ahead and make the multiplication box for this. One thing that does make this easy, because they have common denominators, it should be easy to at least add these without a lot of manipulation. So this will be x plus 2 over 5, and then x minus 1 over 5. So that'll give me x squared. This will give me 2/5 x. This will be negative 1/5 x. Now 1 over 5 times 2 over 5, negative 2 over 5 times negative 1 over 5 will give me negative 2 over 25. So I have that here. If I combine across the peanut again, like here, 2 over 5 minus 1 over 5 will be 1 over 5. So this will be x squared minus 1 over 5x minus 2 over 25. And that's going to be my final answer for question like 6. Well, I did 7 and 8 in class, so I'm not going to go through those again. Okay. I also did 10 and 11 in class. I'm going to show number 12, because I'm sure that's probably a question students are wondering a whole lot about how they would do that. So let me make sure that this is visible for everyone to see. So 12 is asking the question, well, if I take the quantity of x minus 4 and cube it. So how do we go about doing a question like this? Well, we should probably expand this out to get some sense of what this is. So x minus 4 cubed is going to be x minus 4 times x minus 4 times x minus 4. And there's nothing that will enable us to do this question in one foul swoop, which means we're going to need to chunk this, and we're just going to go ahead and we're going to multiply the first two. And whatever result we get, we're going to multiply that by x minus 4. So if I said x plus 4, I might have misspoke. So I'm going to go ahead and make my multiplication box for multiplying these two things out first. So this will give me x squared minus 4x minus 4x plus 16. If I combine my later terms, which I'll go ahead and do up here, that's going to give me x squared minus 8x plus 16. So now I have the product of these two binomials as being x squared minus 8x plus 16. I now have to multiply that by, sorry guys, I didn't realize it was off the screen there, but there it is. I have to multiply that by x minus 4. So if you were looking for this, I have x to the x minus 4 cubed equal to x minus 4 times x minus 4 times x minus 4. I multiply these two together first to get this result. So now I have a binomial times a trinomial. And we're going to go ahead and we're going to multiply this out now. So I'm going to create a longer box now for this calculation. And here I'm going to have x minus 4 times x squared minus 8x plus 16. So this gives me x to the third minus 8x squared plus 16x. This gives me negative 4x plus 32, negative 4x squared plus 32x minus 64. And as I showed in the questions we went over in class yesterday, here I've got a couple of peanuts I'm going to get here. It doesn't always work this way, but here, since the variables and exponents are the same, we can combine these. This will yield a final result of x to the third, negative 8, negative 4, negative 12x squared plus 48x minus 64. And that's going to be the final answer to, at least in that particular question, question 12. Okay. So what I'm going to do in the following question here is just set this up, and we'll probably just go ahead and solve it here. So question 13 reads, it says to find the area of that rectangle. We've done a few questions like that before in class. We talked about how we find the area of a rectangle, and I'll leave that picture there so you can see it. Making sure we kind of maximize the area as much as possible to write on. So we mentioned before that the area of a rectangle is found by taking the length and multiplying it times the width. So in the picture, we'll go ahead and label this the width. We're going to label this measurement the length. That being said, then the area here is going to equal 3x minus 7 times the width. Let me cross that out again. Oh, that's okay. I realized I just could have put a plus there and made things easier, but that's all right. So the length is equal to 3x plus 7, and then the width is equal to 3x minus 7. All right, so from here, what's going to happen is, if we multiply this out, and we'll use a box to do this here, a multiplication box, and I'll kind of move my work over to here at this point. By the way, anytime you'd like to try these questions, feel free to stop the video. As I was demonstrating in class yesterday, just so that you're not just watching the work here, you can try this and make sure that you are refining your ability to do and use this multiplication box correctly. Please take time to do that if you wish. So this is going to be 9x squared. This is going to be plus 21x. This is going to be minus 21x. And this will be minus 49. Now, again, because these are both x terms, we have our peanut for which we can combine. However, what you'll notice is where if this is plus 21, if this is negative 21, they actually cancel each other out and it's 0. So the final answer is going to be 9x squared minus 49. One of the things that we'll learn about later in the question like this is that this question, we'll approach this question with later, is factoring this as what's called the difference of perfect squares. And that's a type of factor they're going to learn about next week in class. In fact, if you go to Module 4 on my lessons online, you're going to find a lot of supplemental videos around multiple types of factoring that I think will be very helpful. Okay, let's see what we've got next here in terms of homework questions. I think there's only a couple left in this section. Yes, there is. Okay. So again, I'm going to do this section, but this is going to count for 3.4 also, as the technique for using the multiplication box is applicable to 3.4. So I won't have a separate video for that. And this question is asking for the area of a triangle. Now, where this one gets a little tricky is, if you're going to find the area of a triangle, which I'll put a little t there for the triangle, it's going to equal 0.5 times what we call the base times what we call the height. So what I'm going to do is I'm going to identify this as the base, and I'm going to define this measurement as the height. And if I put everything together, this is going to be 0.5 times 8x minus 7 times the height, which is going to be 10x. Now, if you follow this and plug this in like identically to what I've done here, this can be a little harder to work with. First off, we have this 0.5, or some of you will know that as 1/2. So that makes things a little cumbersome. One thing that might make things a little easier is, let's just switch this around. So I'm going to write this as 0.5 times 10x times 8x minus 7. Now, in this particular question, if I take 0.5 times 10, just do that, 0.5 times 10 on your calculator, that's going to yield for us 5x. And now it's going to be 5x times 8x minus 7. So what I'm going to do now is I'm going to go ahead and distribute this through. And 5x times 8x will give me 40x squared. And then 5x times negative 7 will give me negative 35x. And because this is a measurement for area, this is going to be, and because this is inches up here, this will be square inches. In the last question, just to kind of go and touch on that quickly, when I gave the answer to it, I believe they gave the answer as 9x squared minus 49. But because the measure of that was in yards, I should be sure that I should show the answer as in square yards. So just want to make sure to include units because I've been neglecting those a little bit in a few of these type of application problems. Okay, one last question from this section. It says, write the following as an equation and then solve. So let's see how we do this. So you remember we learned about the chunking. Okay, so when we're looking at a question that involves an equation or writing an equation, the first thing we always want to try to find is the word either is or is equal to something that's going to separate the left-hand side of the equation from the right-hand side of the equation. So for this, I have is equal to is right here. All right, so I'm going to have something on this side and something on this side. Now, each side may be complicated, and I think that works out to be the case here. So we've got this chunk, but we may need further chunking on each side. Okay? Let's take a look at just this side here. Twice the difference of a number and 6. Okay? Twice. So twice is 2 times. Hopefully you know that. So we have 2 times. The difference, okay, so we talk about the difference. This means that there's going to be subtraction going on here. And because it's twice this quantity, we're going to put a parenthesis around it. So what's the difference? Okay, so we have the difference now. We have that accounted for. A number and 6. So in this case, because it's the difference, we know there's no from here, we're just going to go in order. Twice the difference of what? Of a number and 6. Number and 6. Left side is completed now. Here we go. This says 3 times. So hopefully you go 3 times the sum. Okay. Now when you see like here, like the difference of this and that, like here's the subtraction of this, the number and 6. Here we have 3 times the sum. So we have this quantity here. This is going to be a sum on the inside of this now. The sum of what? The number and 5. So this is where the plus sign goes because that reflects the sum of this and that. The sum of a number and 5. So this is the number, this is 5. So that's how that word problem is negotiated there. When we have this together now, you see we're going to have some distribution to carry out. So we're going to have, in this case, 2x minus 12 equals 3x plus 15. If I move a few things around here, I'm going to have 2x minus 3x equals 15 minus 12. Sorry, 15 plus 12. by moving this over here. So I think that I've done that right. They'll give me negative x is equal to, let's see, 15 plus 12, that's 27. Or if I divide by negative 1, make sure people can see that. Yep, okay. I'm going to have x is equal to negative 27. And that should be my final answer to question 15. Well, that summarizes section 3.3. Let me just take a quick look to make sure there aren't any questions in 3.4 that are really unique here to this. No, nothing unique about that, nothing unique about that. All those questions should be very in the doable range. So we're going to come back to the 3.5 momentarily.